If you look closely at the spacecraft that have left Earth over the past half-century, you will see familiar shapes and designs recurring over and over again. Generally, you will see a rocket, the shroud, and finally the blunt-body aeroshell that brings a payload through the atmosphere. The reason the shape of the aeroshell has changed little over the years can be summed up in one word: physics. When a spacecraft enters the atmosphere of a planetary body, physical forces like drag, pressure, and heating affect the craft. Because the basic blunt body shape works so well to combat the physics of entry, descent, and landing, it has remained the gold standard for decades. But in order to fit into the rocket shroud, aeroshells have to be relatively small. Even the largest aeroshell ever designed specifically for the Curiosity rover is too small to accomplish many of the goals researchers want to achieve on Mars. Worse yet, it's as large as we can build and still fit into existing rocket shrouds. Unless something drastically changes, we are relegated to sending relatively small rovers to very specific spots on Mars. But a small team at NASA has developed an idea that could be the game changer we needed to begin fitting larger aeroshells into smaller rocket shrouds. Called HIAD, or Hypersonic Inflatable Aerodynamic Decelerator, this idea has the potential to revolutionize entry, descent, and landing on planets like Mars and also back here on Earth. On this episode of NASA X, we will follow the HIAD team as they begin real-world testing of this concept with IRVE-3, or the Inflatable Re-Entry Vehicle Experiment. With a short timeline and a small budget, the team worked through numerous challenges to find out if this type of device has what it takes to land future manned and unmanned missions on the Red Planet and beyond.